Hi, good morning, everyone. So let's go to today's lesson. So today we're going to talk about the accumulation function and see we're going to use it to solve some problem. So let's recall the accumulation function. So if we have a g of x equal to integral a to x f of t dt, we call this accumulation function because g of x accumulates things from t equal a to t equal b. So what kind of stuff the g of x accumulate? It depends on the unit of the integrand f of t and the time dt. So now let's take a look at example number 1. We have g of x equal to integral a to x f of t dt. So the integrand f of x is measured in miles per hour and t is measured in hour. So one more time, this have a unit of miles per hour and the time is an hour. So we recall what we learned before, the integral equal to Raymond's sum. So now let's take a look at this in form Raymond's sum. So we say that integral a to x f of t dt equal to base times height plus base times height plus base times height, and keep going. So b1 times h1. So we say that h will be f of t1 times delta t, and then plus f of t2 times delta t, and then plus f of t3 times delta t, and keep going. So because the unit of f is measured in miles per hour, so therefore f of t1 is measured in miles per hour, and then the time is measured in hour. So we get miles per hour times hour, and plus miles per hour times hour, and plus mile per hour times hour. So we know that this cancel each other. We get miles. This cancel, then we get miles. And this cancel, we get miles. So we get miles plus miles and plus miles, and keep going. So we know that miles per miles equal to miles. So therefore, the g of x is measured in miles. In other words, the integral will have a unit of miles. So now we know that g of x is accumulation function. So in other words, we accumulate miles. Let's take a look at another example. So we have h of x equal to integral hx rt dt. RT is in gallons per minute. T is measured in minutes. And then we know that integral h of x rt dt equal to base times height plus base times height plus base times height, and plus, keep going. And now we know that the height is going to be in r of t1, and then times delta t, and plus r of t2 times delta t, and plus r of t3 plus delta t. And we know that the r of t is measured in gallons per minute. So therefore, over here, when r of t1 times delta t, we get the unit gallons per minute times minute. And this will cancel and become gallon. And the RT2 times delta t, the RT2 had the unit of gallons per minute, and the minute and minute cancel, then we got gallon. So we keep going this way, we also cancel the minute, we get gallons. So at the end, we end up with gallons plus gallons and plus gallons plus gallons. So gallon plus gallons will be gallon. So therefore, the unit of the integral from a to x of t dt will equal to gallons. So now I believe you already see the pattern. So in conclusion, to find the unit of the integral a to x f t dt, we can simply multiply the unit of the Ft and delta T. Now let's take a look at next example. Example number 3. So we have h of x equal to integral h of x ft dt. Ft is measured in feet per minute, and t is measured in minute. What is the unit of the integral h of x ft dt? Accumulate. So we just have to find the unit of the ft, which is feet per minute. And then we find the unit of the time, which is in minute. The denominator and the minutes cancel, so we got feet. So that means the unit of the integral h of x ft dt is in feet. Let's take a look at number 4. So we have the f of x equal to integral a to x rt dt. In the integrand, rt is measured in students per second. T is measured in seconds. What is the units of the integral a to x rt dt? So we find the unit of the RT, which is students per second. And then we find the unit of the time, which is in second. So now we cancel this, and we got students. So therefore, the unit of the integral a to x RT dt is students. So that means the integral accumulates students. Let's go to question number 5. So we have h of x equal to integral h of x rt dt. RT is measured in dollars per hour, and then T is measured in hour. What is the unit of h of x? In other words, the unit of the integral h of x rt dt. So now we know that h of x equal to integral h of x rt dt. So the unit of rt is dollars per hour, and the unit for the time is an hour. So we cancel, so we get dollars. So therefore the unit of h of x is dollars. So one more time, all you have to do is multiply the unit of the integrand and the time, dt. Now let's take a look at question number 6. Number 6. A pump is pumping water into a tank at a rate R of t. The rate R of t is measured in gallons per minute. R of t equal to 50 times t. T is between 0 to 10. What is the unit of the integral 0 to 10 R of t dt? So how do we solve this problem? So we are going to look at the unit of the R of t, which is gallons per minute. And what's the unit for the time? Definitely it's a minute. And then we multiply and simplify. Then we got gallons. So therefore, the unit of the integral 0 to 10 R of t dt is gallons. Now let's take a look at part B. Find the number of gallons of water pumped into the tank from t equals 0 to t equals 10. Then how do we solve this problem? Pump into the tank. So we know that the rate RT is measured in gallons per minute. It is the rate the water is pumping into the tank. And we know that integral a to b RT dt will give gallons, accumulation of gallons. So we put all this together. So in order to find the number of gallons of water pumped into the tank from t equal to 0 to t equal 10, it means we do integral 0 to 10 RT dt will give us the number of gallons pumped into tank from t equals to 0 to t equals 10. So one more time, because the integral 0 to 10 RT dt, we accumulate gallons of water. So therefore we use this to help us to find out how many gallons of water was pumped into it. So once we get the idea, so the next step we just had to evaluate this integral. So RT was given in the beginning was 50t. So now we put 50t dt. Now I'm going to integrate this by hand. So the antiderivative of 50t become 50 times t squared over 2. And you had to put the number 0 to 10 on the right side over here. And then we simplify a little bit. 50 over 2. You got 25. So you got 25 t squared. And now we are going to substitute 10 into t. So we got 25 times 10 squared minus 25 times 0 squared. Now we got 25 times 100 minus 25 times 0. So now we got 2500 minus 0, which is 2500 gallons. So that means 2500 gallons of water was pumped into the tank from t equal to 0 to t equal to 10 minutes. So we finished part B. Let's take a look at part C. When t equal to 0, the tank contains 500 gallons of water. So that means in the very beginning there are already 500 gallons of water in the tank. How many gallons of water did the tank contain at t equal to 10 minutes? So from t equal to 0 to t equal 10, 2500 gallons of water was pumped into the tank. And you have 500 to begin with. So therefore we do 2,500 plus 500. So by t equal 10, we got 3,000 gallons of water. So some people say, is there another way to show the work? Yes. So you may want to write integral u to 10 RT dt and plus 500. How much was accumulated and plus the initial amount. So from part B, we got 2,500 and then plus our initial amount. So altogether, we get 3,000 gallons. Now we finished question number 6. Let's take a look at number 7. Number 7. The production rate of cola in thousands of gallons per hour at the production plant on July 1st is shown in the graph are the following, which best approximates the total number of thousands of gallons of cola were produced that day. So this is measured in thousands of gallons per hour, and this is hour. We want to find the number of thousands of gallons. Number of thousands of gallons. That is the unit we want. And we know RT, okay, has the unit here, thousands of gallons per hour. And T, okay, has the unit of hour. If these two multiply together, it will give us exactly thousands of gallons. So that means integral a to b of t dt will have unit of thousands of gallon. One more time, RT has a unit thousands of gallons per hour, and T has a unit of hour, and this cancel will give us exactly thousands of gallons. So if you want to find out how many thousands of gallons accumulated in the day, so all we have to do is integral 0 to 24 hour RT dt. 0 hour to 24 hour. And this question gives us a diagram. So we learned it before. If we want to find this value, you can use area under the curve. So how do we find the area under the curve? We can use rectangular approximation or trapezoidal sum. So we learned that trapezoidal sum gives a better approximation. So since the question never asks which method to use, so we are going to use trapezoid. So now I'm going to draw trapezoid, and you're going to have 0 to 6, 6 to 12, 18, and then 24. So I'm going to use, okay, delta x equal to 6. So over here and here, I'm going to draw my first trapezoid. And then here, okay, I'm going to get my second trapezoid. And then here, I got my third trapezoid. I get 100, 200, 300, 200, and 100. 1, 2, 3, 4. 4 trapezoids. If you look closely, you find out that it is symmetrical. The first two equal to the last two. So I decided to calculate the area of this 2 and then double it. So now I'm going to find the area of this 2. So we're going to 1/2 times the base 1, it would be 100, and this 200. 100 plus 200. And then I got delta x equals 6. The second one, you get a 200 with a 300. So 1/2 times 200 plus 300 and times 6. So now I'm going to simplify a little bit. So I'm going to get 300 times 3 and plus, this is going to be 500 times 3. So I got 900 plus 1,500. That would be 2,400. So over here, I'm going to get 2,400 plus 2,400. The reason is this 2 together is 2,400, and plus this 2. So 2,400 plus 2,400. So it would be 4800, 4,800. So I'm going to look, that would choice C. So it would be 4,800 thousands of gallons. Okay, so we finished question number 7.